New week, new tech talk. Hi, welcome everyone to a new live stream, a new Zephyr live stream. Whether you're watching us on LinkedIn or on YouTube, welcome. We will give people a few minutes to gather and to join. It might be a slow week. I don't know. Some people are celebrating Thanksgiving in the US, etc. So we will see about the turnout. But as we are collecting people, please say hi in the chat. I'm Benjamin, your host for today, joining from France. And so let's see who we have. And I hope you folks brought your thoughts, questions, things you have on your mind with regards to the new Zephyr release that just went out 10 days ago. Zephyr 4.3 is out. There's been quite a few like highlights and like the various top features, let's say, got already mentioned quite extensively in I think last week, actually, we reminded people a bit about some of those, and it's like the release highlights and release notes are out there. But today, we want to spend a bit of time discussing with our release managers for this release, giving everyone a chance to understand maybe better what it takes to ship something like Zephyr, which is kind of like one of those big open source projects out there. Like it's really hundreds of contributors, thousands of commits that go into each release. So how do we make that work? What are the kind of like processes we have in place? What this means for you as a user of the technology, as someone who might be maybe interested in contributing. The release is out there. There's a video that walks through some of the features. I'm sure, like we worked as a community to highlight some of the top highlights and most noteworthy features and bug fixes and whatnot. But I'm sure we missed a few. So let's that's the whole point of today's discussion. And by the way, I'm not seeing anyone commenting yet and saying hi. I'm just assuming that this is the delay in the broadcasting. But please take a moment to say hello, and I will be bringing in our guests, familiar faces. Actually, I think you've all virtually met already. Chris and Johan, we're our release managers for the 3. Hey guys, how are you doing?
Hello.
Hi, how's it going?
Good. So for those who don't know you, maybe we can spend a few minutes, starting maybe with you, Chris. You're first-ish on the screen. Who are you? Like what? And what do you do? What do you do in Zephyr? What's sort of your background there? Because I think it sort of helps to put things in context. And like there's a bunch of us in the project that happen to be doing Zephyr as they are. Like it's part of their job, right? And so understanding better what you guys do would be great. So over to you.
Sure. Yeah. So I'm Chris Friedt, senior staff engineer at Tenstorrent. Previously at a bunch of other tech companies. Tenstorrent's really great. At Tenstorrent, we build computers for AI, and I like to feel like we're democratizing access to AI. We sell IP chips, cards, desktops, and server systems too, so not just AI. We're also a computer company. And then within the Zephyr project, I'm a POSIX maintainer. I contribute to the kernel subsystem. I actually started off in the wireless area, so I have a tremendous amount of respect for people working in 802.15.4, Bluetooth, etc. What does my day job look like is kind of an interesting question. So I manage a small team, and we're breathing life into Silicon using Zephyr. So that involves everything like writing device drivers, interfacing with subsystem, developing protocols. We test with Twister. So part of what I do is ensuring that CI is running all the time, which is basically like an endless, it's just always improvement, always room for improvement and ways to ensure things are running smoothly. I'd say another big part is just education. So we've got a lot of people new to the team, new to Zephyr. And so it's really helping to assist others and understand how to use and reuse Zephyr. and just being aware of what features are available and how we can best use them for our products.
Yeah, well, and I guess I should mention that what you just described, you've been doing it quite a bit with the community at large as well, like with those issues we have on GitHub that are like a good first issue that people can take and try and tackle, especially people early in career, students and whatnot. You've been helping them do their first contributions and so on. So that's it's always appreciated. Cool. And Johan, how about you? And by the way, where are you joining us from, guys? You're from Canada, Chris, right?
Yeah, near Toronto. I think that's the city most people are familiar with. So.
Okay. Yeah, Canada is a big country.
Yeah.
How about you, Johan?
I'm good, thanks. So I'm joining from Finland, from Helsinki, and I've been with the Zephyr project since the very beginning, really. Actually, even before it was a public project back in 2015, and I got involved implementing the Bluetooth stack, the original Bluetooth stack for Zephyr. So I started. I was working for Intel when I started with the project, and did the Bluetooth stack. I've been the maintainer for it since then. Also implemented the Bluetooth mesh support that we have there, and then there's been some side effects of all of that work, like the network buffers that we have in Zephyr nowadays, which are used by other subsystems as well. So I'm the maintainer there, and then since mid last year, I joined Silicon Labs, and I've been basically helping Silicon Labs go to the next level when it comes to their participation in the Zephyr project. Help figure out what the optimal processes are, doing downstream development, doing upstream development, getting people engaged as much as possible, and so on. Silicon Lab is an MCU vendor doing a lot of wireless products, so that's the focus or the priority that we want to make sure works really well with Zephyr.
Nice. Thanks for that. Yeah, there were some people reporting issues with the feed on LinkedIn. I hope this is working just fine, but I think it is. So please, just chime in if there's any issues. And in the meantime, keep using the comments for also lining up your questions. One thing that I wanted to ask you guys before maybe we dive a bit into like what it takes to actually ship something like Zephyr, like I was mentioning before. Like, what are for you some of the highlights of the release? Whether something that's like a very nasty bug that you're finally happy is behind us, or new features, things. I mean, it might be things that we covered in the release notes and in the release highlights, or maybe something that we missed. Like one thing. Maybe I know one thing for you, Johan, is that you're suddenly you have your hands into all things Bluetooth, and so typically we don't. I mean, there's a lot that's happening in Bluetooth, but it's just so much actually happening that there's not always like one highlight. But maybe you can. There were a few things more worth mentioning, or anything really. Like whoever wants to go first on things that you found exciting in Follow 3.
Sure. So if you just look at the bulk of Bluetooth changes that went in, the vast majority of those are actually targeting Bluetooth Classic, which is an older technology in Bluetooth than what you typically use with Zephyr-based devices. Those contributions are mainly coming from NXP. I think there were some from Xiaomi as well.
Sorry, by the way, to interrupt, but one thing that I should know, and I should have done my research, but yeah, Bluetooth Classic, like this keeps sort of coming back. Like, is this still a thing, or like it's just in legacy devices and it's for supporting like legacy headsets and whatnot, or
I can't speak on behalf of other companies who are making these products. What exactly are their use cases? But I would imagine at least the automotive side to be one of the reasons why it just we can't wash our hands clean of it, because the renewal cycle for cars is so long that when you ship a product, you need to make sure that it still works with like 10-year-old cars and so on.
Right.
So that's probably one reason. There might be other use cases as well, but that's the first one that comes to mind.
Yeah, right. Yeah, that makes sense. Okay.
Yeah.
Sorry, I interrupted you there. Yeah.
That's okay. That's okay. So I mean, the focus in the Bluetooth Classic area has been mainly to the audio profile. So we've had the audio streaming, hands-free profile, also object transfer, which is kind of an enhancement, or can be used as an enhancement for the audio profiles. For example, showing cover art on another device for what you're playing on the source device. And then another large area is also audio, where we got changes for 4.3, which is the newer LE audio side, which is still undergoing lots of active development. I'm not sure when it's going to really start coming down, because there's quite huge specifications for various features there. But that's another area where lots of development happened.
And is this does this include what's called Auracast, or is this something else?
Yeah, that's part of it. I didn't dig into the details, like exactly which areas, but just looking at the commits, that's where the second largest part of changes in 4.3 are.
Yeah, right. Okay. Yeah, cool. Yeah. Thanks for the update. How about you, Chris? Any things, highlights for you in this release?
For sure. So I drive electric cars, and I thought the OCPP thing was pretty amazing. So I'm actually pretty tempted to play around with that when I have free time,
Can you remind us what OCPP is?
Yeah, Open Charge Point Protocol. So ChargePoint is a vendor, I believe, and I think this is their protocol that they're making open to the public. But don't quote me on that. I'm not 100% certain. So, but I helped merge it and helped review it. So that was good. That's one of the things about being a release manager, is you don't get too involved in any one thing, but you see everything just kind of flying by, and it's quite exciting. But aside from that, I would say for TensorTorrent, I'd say a big thing would be the new CPU frequency scaling, and how that ties into sort of profiles and stuff like that. Because it's not every day that a Zephyr device has to optimize for both power and performance. That's kind of a niche area where you're getting into thermals and stuff like that. And I would say that most of the Zephyr devices out there are pretty low power to begin with, so power is not usually a major concern, with the exception of radios, of course, because radio, you do want to conserve every last little bit of power, so you're sipping microamps when you're idle and stuff like that. I think even on data center scales, typically we do want to maximize performance when we're in use, but then bring it all down and to the lowest power state possible when it's not in use. So,
yep. Yeah, those were some great enhancements. And on the topic of the electric vehicles, and so I drive an electric vehicle as well. The thing with OCPP, I mean, it's great, but it is really the protocol between the charging station and the cloud. So that's not necessarily the first thing you would think of hacking, because it has nothing to do with the car to some extent. It's really just if you were to build your own charging station, then yeah, you could build it on top of Zephyr. But it's really quite cool. It's nice to see those new standards that are modern enough that it's not XML based anymore. It's more like WebSockets and JSON, that kind of stuff. And writing the stack on top of Zephyr, I mean, everything's there already. You have the JSON library, you have the WebSockets library, TLS integration, etc. So that's that's quite nice. I hope to see more of those, by the way, more of such.
I was going to say that's another area that I feel always gets continuous improvement at Zephyr, is networking, protocol support, and that sort of thing. So you mentioned WebSockets. JSON is obviously critical to IETF standards. So yeah, I'm always impressed with how quickly the network subsystem is moving.
Yes, and hello to everyone in the chat, including people. Louis, hi, congrats on the release. Thanks for the effort. Well, right back at you, Louis. It's really been a community effort, and many people I know that many people watching are actually people who are contributing one way or the other. Dave and Charles, and I mean, everyone basically showing up. There's a question from Fabio to Johan, I guess. What's the current BLE version supported in Zephyr? I guess Zephyr as in main, possibly, or maybe for the 3. Could be both if you know the answer, Johan. But
Yeah,
like 6.2 is just barely out, and we do support some of those features.
Yeah. So I mean, one thing to realize when it comes to Bluetooth versioning is that they're generally always backwards compatible. So adds new features, but the features are mostly optional. So the information you get from saying that you support this Bluetooth version is fairly minimal in the sense that you don't know actually what of the new features are supported. But the 6.2 release of the Bluetooth core specification, that one went out early this month actually, so it's that fresh. We managed to get one single commit into the release for that, which is basically the host stack is able to decode that the controller supports that version. That's it. That's what we got in the 4.3. But after 4.3, we've had a couple of pull requests which have been merged specifically for changes in the 4.3 spec. One of the features is something called shorter connection intervals, which allow you to shorten the interval from milliseconds to microseconds, basically, and you end up getting much better latency with that. So that would be something you'd want for like gaming mice or controllers, these kind of things. There was one security-related change also in how we treat legacy authentication methods for legacy pairing in Bluetooth, where we now don't consider that such a pairing to be so-called authenticated anymore. Rather, it's considered unauthenticated. That's not something that's going to be very visible in the use, but just a security enhancement, the new version. But I would expect us to, before 4.4, to get even more features. But I guess the fact that we can decode the version number, we can already say that the host stack is 6.2.
Yeah, totally. Well, and kind of related, can you talk briefly, and I'm actually genuinely interested, like personally myself, like what does it mean, like that for Zephyr to have Bluetooth support? There's also like the stack is actually certified, right? Like how does that work basically for users?
Yeah, so to be able to claim that you have a Bluetooth product, you need to do what's called the Bluetooth qualification for it. You can either do qualification parts, so that you do subcomponents and then you create a product listing out of that, or you can do just a monolithic product listing where you need to include everything that you qualify. The Zephyr project itself hasn't been very actively doing the formal qualification listing itself. It did that for a couple of releases. I think it's, I don't know, maybe 5 years ago. Actually, we became members of the Bluetooth special interest group specifically to be able to do that. But since then, what the project has done is to strive for qualifiability. So we invest in doing the testing for the Bluetooth support in Zephyr, making sure that it passes all the qualification tests. But then the last step, which actually costs money, that you need to pay to the Bluetooth special interest group, that we haven't done as a project for several years. So the test evidence is there, but not the last part. Here it's important to mention that there is actually a plan next year that the Zephyr project would start doing this again for the Bluetooth stack in Zephyr. I'm not 100% sure the budget has yet been finalized. It should be roughly now that the governing board is deciding on that. So please take this with a grain of salt. It might still change if it's not official, but hopefully we'll start seeing this for the Bluetooth host stack in Zephyr, starting with Zephyr 4.4, that will have Zephyr project qualification listing for it. That said, for even prior releases, you have the vendors doing Zephyr SDKs, performing the qualification and creating qualification listings for it. I know we'll be doing that for Silico Labs. I know other MCU vendors have been doing it as well. So that's something you would need to ask if you're not using that hardware. It gets a little bit into muddy waters on can you refer to such listing or not. Now, I mentioned that the qualification is often done in so-called subsystem listings, and I was talking about the host stack. And when I was talking about what the Zephyr project intends to do, I'm specifically talking about the host stack, because that's the part of the Bluetooth stack which is hardware agnostic. So we couldn't, as a project, start qualifying every single the stack all the way down to the radio for all the different vendors that Zephyr supports. Luckily, there's very good separation between these layers in the Bluetooth specification. So you have the Bluetooth controller, which is bound to the hardware. Then you have a standardized host controller interface, HCI interface, between the controller and the host. And then you have the host stack in Zephyr, which is the hardware agnostic part. So you would still need, depending on which hardware you want to run, even in the future, when the Zephyr projects hopefully starts doing the qualification listings for the host, you will still need a qualification listing from that vendor for the controller.
Yeah, right. Okay, cool. That helps. And it feels like your internet connection might be slightly slow or something. If you have a chance to maybe downgrade to, I don't know if you can downgrade to 720p if you're not already in the camera settings, that might help. Otherwise, you will have to do the audio is mostly fine. So that's there's that. You didn't cut off on that front. So one question that I have to the audience, and for those of you who are joining on YouTube, LinkedIn, etc., would be great to hear what is the feature that you guys features or bug fixes or anything really that you found particularly exciting in for the 3 would be would be great to share. And while we are collecting your input and feedback on that, and the next topic, I guess, would be to understand better the whole release process. Like, how does Zephyr works when it comes to shipping new releases? You guys were on point for this particular release, but there's a bunch of us that are quote unquote release engineers, and that help with some aspects of the process. But yeah, like just in general, like how does that work? Like what was your job as a release manager, basically?
Sure.
So first, or do you want to go first? I'll go first. Sure. Yeah. So the our job as release manager is really just to shepherd all of the pull requests in that we want to see in the release. Make sure that there's enough attention given to features that are scheduled for the release. And to also help to try and resolve any things that might happen in PRs where, there's unsureness of whether or not it's, sufficient and that sort of thing. So, and also just to periodically remind reviewers, oh, this has been sitting in review for some time. I'm always amazed by how exponentially, I would say, the development velocity has gone in Zephyr since I joined. So I used to be the 2.7 release manager for LTS, and even since then, it's huge. It's been explosive, the growth, and so I think actually having like this team of release engineers has been incredibly helpful too, because we've got people all over the globe now that are periodically checking on the status of various subsystems, or reminding users that they have to use a form if they want to fill in a bug report, and like linking those to the respective PRs. So I'm using my hands a lot. And also, I mean, with Johan, we've had this kind of, release manager pair programming happening, if you will. So it's been nice that he's been able to do stuff while I've been sleeping and vice versa.
Yeah, it helped that we are in different time zones.
And were there, I think you sort of reminded me that that's one improvement, I guess, that we made over this release cycle. As far as I remember, like the fact that now when people submit issues, we have a much more like formal GitHub form where it's more it's harder for people to miss the important information when they submit a bug report, and like we ask for them to like provide a repro and so on. Was there any other sort of like improvements that you guys made in the process? Like, I don't know, like tools, scripts that you came up with to help with managing things, or maybe not, I don't know.
So something that didn't happen for this release, but we've had it for a couple of releases, is the merge list. So this dynamically updating web page, which consolidates, summarizes basically the state of pull requests which satisfy the merge criteria of Zephyr. So for pull request to be mergeable, it needs to be up for review for a minimum period. It needs to have sufficient approvals. It needs at least 2 approvals, from which one has to be the assignee, who's usually the maintainer of the area. There shouldn't be any CI failures. All of this has been manual work that release managers have had to do to keep track of what exactly should they be merging. And this somehow organically just ended up coming to existence. It was Fabio that created this, wasn't it, originally?
Yeah.
And I think it was just at the last moment, because if we didn't have this, it would be overwhelming right now with the flood of pull requests coming into the project.
And I think this is a good way to sort of remind the audience. I mean, some of you as code authors and like submitters and contributors is the word I was looking for. You might have experienced that. Like you do a pull request, and then, I mean, it takes time, and there's like a bunch of conditions until the pull request gets merged, and all of this is hopefully fairly well documented. But it's one thing to document things in words, and it's another to figure out ways to automate things so that, to your point, Johan, we can like deal with the load and like that there's that, but also make sure that we don't make mistakes, because like when someone makes a pull request and potentially there's like it's submitting code to a critical area, we really want the maintainer to approve the change. Or if it's another area that's equally critical, and the person who submits the code and the person that or the persons that approve are all from the same company, that's also something like we need someone else from another company to sort of vet the code and until it gets in. And if you don't have good tools for that, then you end up making mistakes, either most likely unintentionally, but I mean, you know what I mean. So yeah, we are trying to improve on the tooling front, and like off the top of my head, I think it's like 800 contributors on this last release alone, and 7,000 plus commits or something. So it's like it's a lot.
It's a lot.
Yeah.
Actually, I wanted to call out Benjamin. In the last release cycle, you added a button to the merge list that would just pop open all of the different available PRs and tabs, because occasionally you open a bunch and you might accidentally merge one that wasn't scheduled for this release or something like that. So
you just need to know which side to begin merging from the left or right, because that's different between browsers.
Right. Yes. Yeah. Because like one thing, and this is where like the release, some people don't necessarily realize, and maybe some of that is way too much information, not worth sharing, but I think it is to some extent. Again, as code contributors, like people watching us who are making contributions, there's many things you probably don't realize happen thanks to the release managers and the release engineers, but to actually try and make your life easier as contributors. Basically, when we do merge, and that's what Johan was just referring to, there might be like 20 PRs lined up. And as you might have experienced, sometimes PRs, they virtually conflict with one another, right? If you merge one, then the other will have a merge conflict and stuff like that. So yeah, the release managers and release engineers, they do their best so that, I mean, if your PR has been sitting there for quite a while, they will try to merge it first so that you're not the one who's going to have to resolve a conflict, because after all, you've been there longer than this person who just showed up and is making a PR that would conflict with yours. So that kind of stuff. And again, this is where like having tooling helps. There's let's see. There's I haven't looked at the question. I'm going to bring it on screen. Let's see if we can address it. I think actually Dave gave it a shot. General question, but I think we the three of us will have ways to take a stab at it. What is the difference between Zephyr and embedded Linux? Give some application examples, maybe. So that's Harry asking from on LinkedIn. Johan, Chris, do you want to take a stab at it?
Well, we don't have the same kind of, even though we have kernel user space separation in Zephyr in terms of privileges, we don't have a concept of processes running in user space. You always build a single application image, so that's the context. Whereas in Linux, you could have multiple processes, multiple applications running on the same kernel, so it's more monolithic with Zephyr. I would claim that you get your control because Zephyr is still focused on the more resource constrained devices and smaller footprint.
Yeah, I think one way to and Chris, maybe you will take a stab at it as well. But one way at a really high level to sort of cut and draw the line is Linux, and even embedded Linux would be for those like application processors that are like reasonably beefy, and like you can afford a stack that's really rich, and then why not? And Zephyr is maybe more like you have more constraints in terms of the code needs to be small. You don't have lots of memory and so on, and so you need something that's like specifically like by design meant to run on like almost, I would say, like at least one order of magnitude of like smaller target kind of thing. So that's one way to look at it. Chris, anything else?
For sure. Actually, that reminds me of a really good example from this last release cycle. I believe there was an engineer from Alibaba that put together this presentation, and because Alibaba has massive data centers, right? So in large rack scale sort of data center class sort of machines, you have what's called a BMC. I think it's like board management controller, board something management controller. So historically in Linux on these machines on server systems, we've had typically like an A-speed chip that runs Linux running OpenBMC. And that usually requires like megabytes of DRAM, like DDR or whatever, low power DDR. And then of course it'll require some sort of storage and yada, yada, yada. And I guess, so what's quite exciting is this engineer from Alibaba managed to squeeze Zephyr into an even smaller chip, didn't require DRAM whatsoever, and did it all in SRAM. So, and I mean, that shrinks your BOM cost, so your bill of materials, so your products cost less money. It means that, what's really fantastic about this is it means that at least in some layer of APIs, Zephyr and Linux have this sort of minimum compatibility that makes it easier for end users to write their application. So,
and there's the there's also in some cases you don't necessarily have to make like a strong choice, as in, I'm going to be like all in Zephyr, and then I'm stuck with Zephyr for my entire life, or the other way around, I'm going to do Linux and then I won't be able to switch back to Zephyr. We have in Zephyr you can use the POSIX APIs, right? And so you can have code, especially like application code or like protocol libraries and stuff like that can be pretty generic. And actually, one question maybe to you both. Maybe you don't know the answer, and that's fine. But I also think for the three, and I was almost going to call it out, except that I know nothing about it. But there were some developments on the Virt.io front. That's kind of also relevant to that story. Can you talk to that, Chris, or?
For sure, yeah. So Virt.io and libvirt is a pretty large specification that was, I believe, originally developed by Red Hat, and it's all over the place. So, the name says it all. It's like it's meant for virtual machines, for virtualization, and that sort of thing. So if you have containerization in your infrastructure, in a lot of cases, you'll use like PCI virtual endpoints and that sort of thing. So when you spawn a VM, your kernel is talking to a device that's specified as a virtual device and has this protocol that's specified by libvirt. And then you can pass that through to different PCI Express cards or whatnot. And it's not just PCI Express cards or PCI endpoints, but also like UARTs, which are virtual UARTs at that point, that sort of thing. You'll get logging, you'll get storage that's virtualized that way as well. So it's a great, I think it's a great way to kind of span the gap as well between Linux and Zephyr. I don't know, Johan, did you have any comments about Virt.io?
Not beyond that. I mean, I came to touch with it at my previous employer at Intel because, I mean, they have huge CPUs where you can run smaller payloads on like one core and then a bigger one on another one. For example, Linux on the most of the have like a really specialized real-time payload. You might want to do that with Zephyr, and then this comes into play. Like how do you integrate that?
Another interesting thing that's sort of like on the topic of Linux and Zephyr is, I don't think it was last year actually, but Linux finally finished the real-time patch series, which is huge, right? So Zephyr's always been this real-time operating system, right? Which means that it's like a purpose-built device that doesn't really prioritize human responsiveness, but more machine responsiveness. So you'll have like, latencies are very critical and you can address them in a very timely manner. Radio being a prime example. So if you've got a radio connected to a chip that's on the same substrate, you can respond to those radio events with microsecond latencies, versus if you've got a radio that's connected over SPI or something like that, or UART to a Linux host, there's going to be a round trip latency that can affect your real-time responsiveness. So Zephyr has been very strong in that area because it's so small.
Yeah, that's. I hope this answers your question, Harry. If you have follow-up questions, feel free to chime in. So I didn't see many people commenting on what were their favorite features in 4.3, but you still have time to do so. One question, open question, and maybe also an opportunity to learn more about the process and maybe tips and tricks as well for the downstream adopters. Are you guys already planning a 4.3.1 where there are things that maybe missed? I mean, we would typically only like the maintenance releases are only for bug fixes, but still there might be some important enough bugs that were just spotted slightly too late. So do you have already a date in mind, or in the meantime, how can people maybe deal with those patches?
I don't think we have a specific date in mind. I'm pretty sure we will be doing 4.3.1 release. As we were getting to the very last stages before the final release, there were pretty important seeming bug fixes coming in which didn't quite make it into the release, but those we certainly want to get as backports and have as part of the stable branch for 4.3. There's been a significant amount of those already. The audience might not know, we have pretty good automation in place also for managing this. So when you have a pull request, which is fixed for something that you really would like to get into the backport, into the stable branch, all you need to do is to add a label to it, a GitHub label, backport 4.3 label to it. And there's automation in place which automatically creates the backport pull request for you, assuming that there are no conflicts. One additional requirement which we do have for all backports is that there needs to be a concrete bug fix, a GitHub issue that it's fixing. That's not always true for things going to the main branch, but for backports, you need to make sure that you have one.
Yeah, and I think a small correction: put the label or ask someone to add the label for you. Not everyone might have the permissions. But if you don't have the permissions and you feel like you've been contributing quite a bit, then maybe you should have them, and you should actually be a proper collaborator on the organization. And you might want to step up as a maintainer and whatnot. That's a different story. But it's usually pretty straightforward to get your stuff backported, and we probably don't do it enough to some extent, because it's always, I don't know, like every maintenance release, we are in the process of cutting a release for 4.1.1, and I don't know, it's 70 bug fixes or something, which is, I mean, one could say it's a lot, but it's not that many actually. We could have probably backported more. Fabio has a question actually, and something, a good reminder to people watching. If you didn't get the memo by now, you should have. But if you haven't, we are moving away from releasing basically 3 times a year, more or less, to twice a year, to releasing in April and October of each year, starting with the next release with 4.4, which will be released in April of next year. So this gives us slightly, well, this makes for longer release cycles. That there's one, and this makes for more predictability as well, because the way the previous schedule was done is that it would keep sort of like shifting by a few weeks here and there, and like always ending up in the middle of vacations somewhere in the world, including summer vacation, etc., etc. April, October, at least, yeah. This is maybe more manageable this way. Question applies to the audience as well, by the way. But do you guys, Chris and Johan, have thoughts on that? Like, where you're actually looking forward to this kind of change, or thoughts?
Yeah, I think it's pretty good. I like to see more features in Zephyr. So from that perspective, it gives people a longer window to make sure that their features get in. And I think that's always been kind of an issue with shorter release cycles. It's like, okay, well, we have, a couple of months or 3 or 4 months to get to a feature freeze. And within that time, everybody's trying to get their features in. And as the project grows, reviewer and maintainer bandwidth shrinks, unfortunately. So, the PRs might not get the same amount of attention as they deserve, prior to release. And I think this gives the opportunity, to maintainers to see everything that they should see in order to make sure that they get the reviews in on time and stuff like that.
Yeah. The flip side of that is, of course, that if you miss a release, then it's going to be a bigger penalty. You're going to have to wait 6 more months to get it in. So I could imagine that towards the end, or towards the final release, there's going to be more pressure in everything that's been brewing up until that point to get that merged. So it will be interesting to see how, if that dynamic changes. And I think ultimately we'll just need to see how it goes. I think it's going to be a good change for the most part. We are, after all, aligning with how many big projects do the releases twice a year. It's also, of course, a bigger commitment for the release managers like us. So it's going to be we are, as release managers, we're not actually just responsible for getting the 0.0 release out. We also do the stable branch, and the promise that the Zephyr project gives is that we support the last 2 stable releases. So with the previous cadence that the project has had, it's been 8 months since the project has had a 4-month cadence. So we are on the hook for 8 months after the release. Now that's going to change to a year when we move to the new cadence.
Yeah, that's a good point. But like you said, everything is automated mostly. But yeah, no, it's yeah, there's a lot that can break, and yeah, you guys are certainly doing a great job there. I also wonder if like, given that there will be releases less often, maybe this will and maybe for better or worse, actually, this will get people like downstream users force them to some extent to make sure that their downstream development is properly set up, in that if they do really need something that, I mean, they submitted the fix upstream, it's been accepted and so on, but I mean, of course, it hasn't been released just yet because it's going to be another few months. It will sort of force them to figure out their processes so that they are able to build something that's like virtually based on the to be announced and to be released N+1 version of Zephyr, and yet have their own patches applied and stuff like that. So there's actually it's kind of a segue into a tool that I don't think maybe many people know exists, but you've been working on, I think, Chris, West Patch. Like there's effectively, and again, this is for better or worse, because like we know what can happen if people end up sort of like maintaining patches that they just forget about contributing upstream. But we have a tool that makes it easier to have those patches that, yeah, please talk to it.
Sure, yeah. So coming from previous experience, I find that especially in really large companies, people tend to fork an open source project, and because it's in version control, they're like, okay, well, I'll just make as many changes as I want to in tree to get my my application or my product out the door. So that's really good. It's like a short-term reward for the person that's authoring that feature or application or whatever. The issue with in-tree changes, and to a large extent, our module architecture, Zephyr has this modular architecture where you can create a separate module and pull that into your build with relative ease using the manifest file, west.yaml. So to a large extent, having your own module helps a lot. But as as Benjamin pointed out, we typically do want to synchronize with releases of the Zephyr project. So, and I was doing this in the last release cycle because as a release manager, I want to be able to say, I give this my stamp, it's working to the best extent that I am able to make it work on our hardware. So in our CI, in our repository, our processes and our code format and all that stuff, most of our checking is really close to what happens upstream in Zephyr. So that means that we can submit patches upstream with relative ease and not have to worry about compliance issues. It also means we can pull down patches with relative ease because we know that anything that's been accepted after the release date is probably going to merge really easily into our own tree. So now I created this tool called West Patch because for those companies that do in-tree development or out-of-tree development in their own module, it just gives you this, I'm not going to call it a standard, but it's like a very regular way to make visible the contributions that you want to upstream and those that you cannot, and whether or not those have been accepted already for viewers of your module repository, and so on and so forth. So now, as the release approached, especially after feature freeze, we were up-revving our commit that we were building against in Zephyr on a weekly basis. So this, first of all, made sense for us because we could say, oh yeah, with Zephyr 4.3.0, we are working on the latest builds, good to go. So if you're about to release a product, this really allows you to say, we're ready to hit the road running with Zephyr 4.3.0 or the next release and so on and so forth. But it also allows us to basically schedule when we can work on upstreaming fixes and that sort of thing. Or if someone from the Zephyr project just happens to see our repository and says, oh, here's a patch for a feature I maintain, I can see the value in that. They just pull it. And it's also quite simple too, right? So, or other people in other companies might have the same problem. So.
Yep. But it's a really nice tool and yeah, great documentation as well. So yeah, give it a try if you haven't already. West Patch, it's already integrated in Zephyr. There is a question from Josef. Are there plans for, let's say, a unification and increased robustness of the driver subsystems when looking at networking graphics? There seems to be like a happy path where it works well with a given board, given shield, and then maybe not so well with different combinations. Do you guys want to take a stab at it?
Sure. I actually know Josef, so this is a great question from him. I think that there's been some kind of planning and discussion within the Zephyr project to have specific hardware, boards, platforms, whatever, tested by the vendors that sell them. And I think that that's an area where Upstream and Zephyr, there's a little bit of a gap right now. So we do build drivers, we ensure builds continuity. We test as many drivers as we possibly can in virtualized platforms, QEMU, Native Sim. Renode is a great virtualization platform as well. But currently, we don't run tests on boards in Upstream CI because there are, I don't know, like, what is it now? Close to 1,000 different boards that we support.
Yeah. If you include the shields, yes. But to answer the question about like, are there plans? We do have budget and a plan already to do more of what Chris just described, like basically enabling testing on real hardware. So this doesn't mean, this will lead to unification. To your point, Joseph, doesn't necessarily mean that everything will sort of automatically works on all the possible combinations, but at least we will set better expectations in terms of, this has been tested, and maybe this has been tested and this doesn't pass, but at least bringing some visibility on those test runs and so on. But this is we know that this is an issue. So.
I think a lot of downstreams have been doing this testing, but what's been missing is collecting that information to a centralized public place, so that there's a good overview of what should be actually working.
Yeah, and I guess putting my documentation hat on, I think there might also be some opportunities to surface some health indicators in terms of, this driver is like, it hasn't been touched in years, which sometimes is not necessarily bad per se, but it hasn't been touched in years. It belongs to a driver area or driver subsystem that's not actively maintained. Yeah, here's your orange flag. Like, it's not green, it's orange. I take it with a grain of salt. If you want to try it, it might or might not work. And if you combine that with the actual test runs on actual hardware, etc., that gives more signals for people to make their decisions and maybe realize that, hey, you know what, I'm going to try and find another sensor if this one smells like it won't work, kind of stuff. So, but yeah, great question. There is one, and please do line up the questions. This is great that they are finally coming. This is a question from Aaron. Can you tell me more about the debug capabilities built into Zephyr for ARM and RISC-V? There's hardware support for instruction traces. Is this something that Zephyr supports to collect the trace data? Can either of you talk to that? I mean, there's many ways to debug and trace and profile. We have also the new instrumentation subsystem that just made it in 4.3. Anything else that you guys want to add on that?
Generally speaking, I think that Zephyr focuses on making like as much as possible like hardware agnostic interfaces. But of course, we do support like architecture specific interfaces for that as well, to the best of our ability. One really interesting, so not necessarily trace and debug, but a really key technology that was introduced in ARM recently was, I think it's called SCMI, ARM SCMI, which stands for System Configuration Management Interface. So there's also an analog in the RISC-V world called RPMI, which is RISC-V Platform Management Interface. And it's a standard. It's part of the RISC-V standard, so it's a published thing already, just like ARM SCMI. So system control, I bet. Yeah. So these are it's telemetry. It's a little bit of this, a little bit of that, but it's a standardized protocol to list like temperatures, frequencies, querying various bits of registers and stuff like that. Pin control. Yeah. I mean, there's a lot of different ways you can put common functionality together like this. And I think that really that helps partners in the ARM or RISC-V communities as there to develop standardized tooling and stuff like that. So now I believe both of these standards also allow you to tunnel vendor-specific bits or provide vendor-specific keys and stuff like that, so that you can query various bits of telemetry that are specific to your hardware. So all this is pretty foundational. And then I think that individual vendors might improve the standard and offer their own bits and pieces as well. So it's kind of interesting.
Yeah, right. And yeah, I think it might be Briggs pointing it out in the chat, but the to answer Aaron's question, this might not be what you're looking for in terms of like hardware support for like actual processor instruction traces, but like generally speaking, we have like tracing capabilities and a new instrumentation subsystem that was added to for the 3, which makes it much easier to, including at runtime, to be like, hey, I want to trace and figure out the flow of my system when I enter and exit this particular function. I care about spying on everything kernel, but anything driver, I don't want to instrument that. So all that kind of stuff like this. Yeah, there's actually some great documentation too. You even have the pointers to that. Question from, and we have only a few minutes left, but let's take as many questions as we can. Question from Philip Dillon. I've seen there are 3 different APIs for audio in Zephyr, I2S, DAI, and DMIC. These have different capabilities too, but some are close. Are there plans to unify them at some point? Maybe you're answering your own question. Maybe if you have interest in this area, because to the best of my knowledge, I don't think we have anyone right now who's sort of like actively maintaining any of those audio-related subsystems. I might be wrong, but I think that's the case. So yeah, there might have been some stuff introduced at different points in time. If you feel like there's some unification needed, it might be worth discussing, like open an RFC, bring it up to the architecture working group. You might have heard me like personally like mentioned in the podcast and elsewhere. It feels to me as if Zephyr has like really great things to offer audio wise, if you know what you're looking for. And I wish we would have more code samples and stuff that just would help make things easier. And apparently you're sort of making the point that we might even have some fragmentation in the subsystem. So do any of you guys have any experience with any of those subsystems or those you want to share?
Johan.
No, I don't.
Not really.
Yeah.
I mean, I know that like I2S, for example, some of these things are kind of like fundamentally different in terms of hardware and like IP and stuff like that. So if you're writing a driver for I2S or I2S, whatever you want to call it, that's usually specific to a vendor IP that's dealing with audio I/O. It might be that the IP can be multi-purposed. So that really depends on the hardware vendor. But I know that Benjamin mentioned, I believe this week too, like something about how it would be great if maybe it was on the podcast, guitar pedal running Zephyr.
Yeah, totally. But I sort of thinking out loud, and I think we have the same, and I don't know if we have anyone watching the stream right now from the working on the video stuff we have in Zephyr, or display to some extent are the same. It kind of feels as if maybe what we need and might not really have is some general like audio processing libraries, and then there's the hardware drivers. And I think to some extent this is what the video folks are doing with like the video subsystem. Yeah, there's all like the camera drivers, etc., but anything image manipulation and so on, this is handled separately and sort of as a library, as opposed to something really tied to the hardware. So maybe there's some that's maybe one way to move forward, but I know nothing about audio. But yeah, Philip Dillon, please reach out offline and or open an RFC to discuss those. Those are actually great points and exactly the kind of questions that I was hoping we would get. With that, we are reaching the top of the hour. I don't see any questions that we didn't address. So thanks everyone for tuning in. If you're watching the replay, that works too, and you can ask questions in the comments. We will make sure to address them. If by now you haven't subscribed to our YouTube channel, you are missing out on the podcast stuff and the various tech talks that we put out there. So please, please do subscribe. And Johan and Chris, good luck for what's now a 1-year duty, as you pointed out. But thanks for all the work, and thanks for showing up today and sharing your insights. Thanks, everyone. Bye.
Sure.
Thanks.
Thanks. Bye.